Right, so what we're going to be looking at today is RAM, ROM, and virtual storage. Now, any of you that have been doing this before as a subject, you'll know that RAM and ROM are two very different types of memory. One is read-only, which means you can, once it's been written, that's it, it stops. And RAM is basically it loses its saving power once the electricity's gone, that information's gone. So we're going to talk a little bit about that. Now, what I want you to get from today's lesson is you're going to learn about what RAM and ROM is and the difference between those two things, and we're also going to learn about what virtual storage is. If you've done the GCSE before, this will make sense to you, but I'm going to add some elements to it and explain what something called paging and segmentation is to you. All right? So, the difference between RAM and ROM, all right? Computers have two types of memory. RAM is stored in blocks. So if you've ever seen a RAM chip, in fact, it was the very first image on the slide, it's a long stick and it's got blocks on it, okay? It's used to store the programs currently being used. So in an exam, you need to make sure, I haven't highlighted that on there, but it's the programs that are currently being used. So if you've got Microsoft Word installed on your computer, it's not in the RAM until it's running. You've got to acknowledge that it's running, all right? Volatile means that when the power's gone on the computer, the memory's gone, all right? So anything stored in the RAM isn't there forever. And I want you to think about it. Have any of you had files that have been lost before? You're in the middle of doing a Word document and it's disappeared. Yeah? But that's because it's still in the RAM. Until you press that save button, it's not transferred onto the hard drive, which is why you lose it, because the electricity goes, and once your computer restarts, you haven't got it anymore. All right? It's used for the operating system and, again, applications currently in use. So that's RAM in a nutshell. Quite easy. ROM is very different. ROM is a small chip, usually, on the computer, and it's read-only, which means that it can't be changed. It's fixed. And we tend to use that for the bootstrap. So, you know, when you start up your computer, have any of you ever had the screens with all the text coming up it? That's the bootstrap. That's what gets you to Windows. So that's basically a little program that gets you to your operating system. It's used in embedded systems such as washing machines, sat-navs, cars, cameras, and other devices because it's always the same. You don't need to change it. So your washing machine's always got the same operating system. It's always got the same settings you can change. You don't need to change it, which is why it's read-only. All right. The next thing you've got is something called virtual storage. Now, when your computer starts to slow down, this is where your operating system comes in managing your memory, your RAM. All right. The operating system, what it does is it creates something called virtual memory. Now, it's like RAM, but it's allocated on your hard drive. So, say for example, you had let's say we had Microsoft Word loaded and it was running. What happens there is if you're not actually typing into it and you go to use another application like your web browser, the web browser is put into the RAM, but the word processor, Microsoft Word, that is put into virtual storage, an area on the hard drive until it's needed again. So it's a case of moving things about. So any programs that you need, it's like memory management. Any programs that you need are put onto the RAM so that you can access it right away because it's right next to the processor. But with the programs that you don't need, it goes into virtual storage. So it's like it acts as an extension to your RAM, basically. That's what virtual memory is. Now, how it works. If you have a look at the diagram on the screen here, you've got your RAM. And what happens is anything that's not being used, all right, you will use it eventually, but at the moment you're not using it. To save your computer and to make it more efficient, it moves into the hard disk until it's needed again. It's that simple. So the application on your desktop that might not be used is moved and switched back when it's needed again. Is that making sense? Now, there are two different ways of managing memory. You've got paging and segmentation, and I'm going to show you a diagram in a minute in the book which you can actually copy and put on your screen in your books. Now you've got paging. Now paging is where all of the information in the RAM is split, all of your applications are split into equal chunks, all the same size. But what you have is something called a paging table. Now that table basically says, well, if I need that information, I'm going to go to that part of the RAM, that part of the RAM, and that part of the RAM to get the process finished. And it can be stored anywhere in the RAM. It doesn't have to be next to each other. It might be that it's stored in part D and F, but you've got a paging table that links to the information that you need. Segmentation splits it up into processes. Rather than you having lots of little segments, segmentation splits it up so that that process is kept together, that process is kept together. So it's slightly different, and depending on the structure will depend on how big your segments are. All right? So that's how it's split up. Now, what you need to consider on this is that some operating systems, some modern operating systems use both. Some use only one, some might only use paging, others use segmentation. Now, you will have some exam style questions. So page sizes usually have full kilobytes in older systems. Some newer systems have larger page sizes. Discuss the advantages and disadvantages that might occur as a result of large page sizes. So you might need to do a bit of research on this. Why and how do page sizes have an impact on the efficiency or the running of your machine? All right, you could argue that having bigger page sizes mean that you've got more information to process, but that's for you to research and find out. Research what is meant by disk thrashing, so that's going to be another task. But I want you to reference the website that you found, and anything that you use you can quote, but put it in your own words. You've got to get used to referencing, particularly for university, all right? And then explain why adding RAM to a computer might improve its performance. Explain the performance of the machine, but also comment on what would happen to the virtual memory. I'm going to give you a bit of hint with the third question. If I've got more RAM, do I need as much virtual memory? What do you think? I don't need as much virtual memory, so it's going to be smaller. But what impact does that have on the efficiency of our computer? So that's just a quick whiz through of that. I'm going to email you this slide, all right? And that way you've got this now as a revision resource as well. So I'll